So we're very pleased to welcome Jane Evans this evening from Weymouth, Nottingham, to speak to us. Hopefully now we've got all the fraught parts of it. You know, we couldn't even find the right building before. But here we are. So Jane started off with her BSc and MScs in London and Oxford universities, and then in the early 80s moved to the British Geological Survey, then in London, and subsequently to Weymouth, and had an interest in those, first of all, for mainly, I guess, geological purposes, and then subsequently into the world of archaeology. This evening we have a slightly macabre title, and we'll see what isotopes do to unravel this fascinating story here about the Vikings.
Sure, thank you very much for inviting me. Couple of things I'll just say these days. I have got a few pictures of skeletons. I hope that doesn't upset anybody. And one artist's impression of a massacre, but it's not that bad. The second thing, in case there are any archaeologists in the audience about to jump on me, the term Viking is not an official archaeological term. It's not understood. It's not. We can talk about the Viking period, but the term Viking is not specific. But I've just used it in the title. I did get away with it as a paper, so I'm reckoning I can get away with it in the title of a talk. But I'm very well aware that it's not an archaeologically formal term. Anyway, just to say, this site came to our Isotope laboratory. The excavation was done by Oxford Archaeology. The work was funded by Dorset Council. The carbon-14 dating was done at Oxford, and the isotope work was done by myself and my colleague Carolyn Chenery. So I'm going to take you back to 2012, to the Olympics, when a lot of infrastructure work needed to be done to access all the sites that were going to be used for the Olympics. And in particular, the sailing was set in Weymouth. And so in order to improve the access into Weymouth, they improved the roads coming into the Weymouth area. And of course, along with that work, there were archaeologists associated in case anything might be found. And this is a view of the roadworks. And if you can see on the right there with the circle, they did indeed find some skeletal remains. When they investigated this further, it appeared to be a pile of skulls, which originally they thought, was this a funerary deposit? What was this? But as they excavated further, it became a bit more gruesome, because if you can see, the heads are all to the top of the diagram, and the bodies are all over in the rest of the pit. In other words, these are skeletons that have been beheaded, and they think that the heads were then stacked in a pile on the side of the road as a warning. That shows the site a little more obviously. And it is interesting that these bodies are in what was a pre-existing pit. And so there was some suggestion to begin with, what could this be? Was this a long-term execution site? What age was it? This is how they felt that it probably had taken place, that these people had been executed and their bodies thrown into the pit. Now, what was interesting is once they excavated all the skeletons and started to examine the skeletal remains, they had the following observations. There were about 54 men. There were sort of 54 bodies and slightly fewer skulls. And they think maybe a couple of skulls were removed as trophies. The majority of the individuals were men between the age of 18 and 25. But there were a couple of older ones, and the oldest individual was probably about 50. Interestingly, there was no convincing evidence of previous war injuries on them. One of the individuals, I think it was the older one, had a swollen and infected leg. There were absolutely no evidence of clothing or possessions, nothing that you could look at that would give you any clue as to the age or origin of these individuals. And this is where the archaeology started to get a bit stuck. Who were these guys? What were they doing? Why were they executed? Where did they come from? So now I'm going to leave you with that thought while I jump in and try and explain what isotope analysis can do to help archaeology. And just to start off with, an isotope, an element that has different isotopes within its structure, has forms with different numbers of neutrons in the nucleus. In other words, if we thought of oxygen, most oxygen will have a mass of 16, but some oxygen has an extra 2 neutrons to make it 18. Now, the importance of that is that that mass difference, that weight difference you could call it, means that those oxygen atoms behave in slightly different ways when physical processes are applied to them. So, for instance, if you boil a kettle of water, the water that comes off first tends to be enriched in the lighter oxygen and the lighter hydrogen, so we can split the isotopes by applying physical forces to them. In terms of strontium and some of the heavier elements that have isotope variation, these elements, the difference is caused by the fact that something like rubidium radioactively decays to strontium, and so one of the isotopes is constantly accruing, and that's strontium-87, while the others are static. So what happens, and this is how we date rocks in geology, is that we look at the ratio of the 87 strontium to the 86 strontium, and basically the higher the value, either the longer the rock has been there or the more rubidium it had in to begin with. In other words, there is a time factor in the accumulation of strontium 87, 86 values. And to just give a sort of geological example, let's suppose that we've got the Lewisian. The pink, let's pretend that the pink is the Lewisian, and then we've got some sky basalts on top of them. And the Lewisian is a very old rock, so its strontium value is going to be quite elevated, whereas the basalt has low rubidium in it and is very young, so it has a low value. And those numbers on there may seem like they're not that different, but to an isotope geologist, effectively the difference between 16 and 5, which are the last 2 digits, is pretty massive, okay? So what happens is that you've got the underlying rocks. They weather, form soil. The plants then grow on those soils, take up the strontium, which is characteristic of the underlying rock in some form. That gets it into the biosphere. And then you've got animals grazing, you've got people eating plants, and therefore those values transmit up the food chain. And so what we tend to do is we analyze teeth of skeletons, because teeth as an appetite, bioappetite mineral, doesn't get affected by the fact that the body's been buried for some time. And we can look at the isotope composition of teeth, and it will tell us something about where that individual spent their childhood when those teeth were forming. And that's how we use strontium. We can relate it closely to geology, and in a way that's how I got involved in archaeology. And this is the latest map we have of the strontium isotope variations across Britain. It's clearly based on the geological variations, but the isotope variations don't directly reflect the underlying rock, but they indirectly reflect it. They're related to it. And so we can use the analysis of the teeth to try and basically exclude. This is another thing I should always say, because it's a bit easy to say where somebody came from. We can't say where somebody came from. What we can say is where they didn't come from. In other words, if that person has a value that corresponds to the dark blue, which is the chalk, what we could say is that their childhood values are consistent with being on the chalk, and we can exclude mostly all of the others except maybe sky, but we can't say they came from there, but we've excluded a lot of other options. And what we do is we layer cake a number of different type of discriminations and narrow down the possibilities of the geographic origin. So strontium is a very important one related to the geology, and we're very lucky in Britain that we have this very large range of geological time and quite variable geology across the country. It wouldn't work if the entire place was covered in loess. Be a bit boring. Now, another isotope that we use quite commonly is oxygen. And as I've said, oxygen isotopes are affected by physical processes. So what happens is, if you go to the equator, there's a massive evaporation of water off the equator. And then the wind systems pull the clouds north and south. And as they rain out across the globe, they basically rain out the heavier isotopes first. So rain varies systematically from equator to pole. In Britain, it rotates because all our weather comes from the west. So we have oxygen isotope zones that go west to east. The left-hand map shows the variations in drinking water and rainwater that we see across Britain. Now, that's quite detailed. What we find when we look at human teeth is because teeth form over about a year, they average what you drink, a population will be quite diverse. I think realistically we can only really split Britain maybe into west and east as far as oxygen isotopes go, but that's still useful. Okay, so we've got a west to east variation there. Now I'm going to see if I can show you how this works. Will this work? When it works. Control click, control click. Oh, I'm going to struggle here. Doesn't want to work. Okay, never mind. What I was going to show you is a website that we have built where what you can do is you can take the isotope composition that you've measured in a tooth, and that can include oxygen, strontium, sulfur, and lead, and you can enter those variables into this website, and it will then exclude all areas that don't fulfill that particular location. And I was going to show you my favorite one because it's the best there is that I've ever had, and that is an individual Roman that we looked at quite recently, and he was found near Cambridge, and he had an Eastern Britain oxygen isotope value. That didn't really give us much of a clue. He had a rather common strontium value, so that kind of reduced it a bit more. But we did sulfur on him, and interestingly, the sulfur overlying the Jurassic muds has a very distinctive negative value. And when you combine that with the strontium and the oxygen, what we found was that basically his tooth was consistent with him having been brought up 10 miles from where he was found. Now, do I believe that precisely? No. But on the other hand, that combination, and in this case the sulfur, really concentrated in the likely places that he could have been born. And it was very interesting that it came up quite close to Cambridge. So that's how we use it. However, I'm going to have to tell you that in the case of these skeletons we're looking at, it didn't quite work that well. There is another thing that we can look at, which is lead concentrations, because I'm sure, as you're all aware, lead is a pollutant. It always has been a pollutant, and it's dangerous. It's not good for health, but there have been many times when we can be very exposed to lead. And in fact, our generation was brought up before there were restrictions on lead in petrol. And I happen to know for a fact, because I had a tooth pulled, and why waste a tooth when you can analyze it? But I have 7 parts per million of Australian lead in my teeth. Now, 7 ppm, parts per million, really is quite significantly worrying, number one, because I got it in childhood. And it's Australian lead because the source of the lead that's put in the anti-knock petrol here comes from Australia. The upside of that is that we can see that decreasing, and we're getting back to British lead. So we can actually see the loss in the environment of the Australian lead. So it's clearing out. So it's quite useful, that. And yeah, I think you're probably familiar that the Romans, are known to have used lead and suffered from lead poisoning and this sort of thing. So the lead concentrations tell you something about the culture. Is it an industrial culture? Is it a sort of Are people handling metal, drinking out of pewter, having lead pipes, all these sorts of things? So it's another little useful thing to use. So coming back to the isotopes, the first thing that archaeologists normally do once they've done all their skeletal analysis and looked at these individuals is they go for carbon-14 dating. And as I say, they really didn't know when they dug these guys up whether they were Romans. There was a suspicion they could be Roman because they weren't found far from Maiden Castle, which is a famous Roman site. Were they Anglo-Saxons? Who knows? But when they dated them, they came up with a time period of 970 to 1045 AD. This is the Anglo-Saxon Viking period. And furthermore, that there was no significant difference in age between the top and the bottom of the stack of bodies. So this wasn't a long-standing execution site. This was a single execution event. In other words, a massacre. Now, again, there are two models once we're looking at the Viking period of what kind of massacring went on. So the Anglo-Saxon Chronicle, which is an amazing document, points out that one of the earliest Viking period heathen raids was AD 793. And on the 6th day before the Ides of January in that year, the harrowing inroads of heathen men made lamentable havoc in the Church of God in Holy Island, that's Lindisfarne, by rapine and slaughter. So this is massacre by an incoming bunch of aggressors. But on the other side of things, once these populations had in part settled in parts of Britain, there's something called the St. Bride's Day Massacre. And this is when the king, Ethelred, got really edgy about these Scandinavian populations and set up a royal charter in 1004 for the most just extermination of Danes who had settled and sprung up in this island. So we have two options on either of the main sides for massacre events. So this is the point at which we were brought in, the isotope lab, to see if we could have a look at the composition of these people's teeth and find out where they might or might not have come from. This is me cutting one of the teeth up, and what I tend to do is, that's a pretty typical tooth as I receive it. It's a bit grubby on top left. The first thing I do is I use a dental burr to clean off all the outside dirt and grime. I then use a dental blade to slice off a bit of the tooth in the top right. And if you can see that piece that's sliced off, you can see that there's enamel, but there's a slightly browner center to it, and that's the dentine. Now, whereas the enamel preserves its composition, its life composition during burial, dentine and bone don't. So I have to remove the dentine before I can analyze this sample. So bottom left, you'll see that I've drilled out the center of that bit of enamel. So we've got rid of the dentine and we have an enamel sample. And that's the kind of material that I analyze. And I've just popped it into a little test tube. And at that point, I can take it in to the labs. And once we're in the labs, what we do is we dissolve this sample up. We run the solution through ion exchange columns. Now, basically, it's chromatography. In other words, you put a solution at the top of this resin column, and just like ink in blotting paper, see, I'm being naughty, but I'm reckoning from the generational look of this audience that they remember blotting paper and ink to a large extent. It's an analogy I'm using less and less these days. But you know how the ink color sort of spreads out at different speeds. Well, what happens is the strontium passes down the column at a different speed from the calcium and the iron and the other elements. We've got these columns calibrated. So what we do is when we know the strontium is hovering at the bottom of the column, we just put a quick beaker underneath it, add a bit more acid, and hey presto, we've caught the strontium. And we dry that down and we run it on a mass spectrometer. And there you go, that's me in the chemistry lab, and then that's our mass spectrometer. one of the mass spectrometers. That's the one that runs the strontium. We've got a different one for running the lead and a different one again from running the sulfur. So what did we get? Well, this is the strontium isotope data that I got. On the left-hand edge are the strontium isotope values from 0.706, which is pretty much almost impossible to get in Britain, it's so low. The green band that I've put at the bottom, that's what the local Weymouth signature would have been. If they'd all been locals to Weymouth in that area on the chalk, they should have fallen pretty much within that, what's called the local Weymouth zone. As you rise up, you start to get values up to 0.72, which I'm not sure I've ever seen in a genuinely British individual. I have seen values possibly up to 715 and 716, but you're really pushing the limits. There aren't many places that that sort of person can come from. And in fact, probably the granites of southwest England might be a possibility. And again, some of the Scottish granites might be a possibility, but it's a rare value. And so what you can see is, first of all, we have a huge variation in the strontium values that we got, and also some values that seem unlikely to be British. Okay? That was really quite exciting, I thought. But not as exciting as my colleague Carolyn. Now, to me, what science is about, that moment, is when you look at some results, they come out on your mass spectrometer, and you look at them and you go, oh my goodness, that's amazing. And then you look at it again, and this is absolutely incredible. And your brain goes, if that's true, then that's true, then that's true. And then you want to run down the corridor and tell somebody, except then you think, no, I'm just going to check it again, make sure I know what I'm talking about. And you sit there and you think about it. And at that point, Carolyn came thundering down the corridor going, oh my goodness, you should see the oxygen results from these guys. They're amazing. And so they were. So what we've got here is, at the top, is a kind of histogrammy type diagram of what we'd expect for overall British oxygen values in teeth. And that's now based on about 650 analyses from across Britain. What you can see at the bottom is that the main peak there is completely offset to lower numbers. These guys are not British. They did not spend their childhood in Britain. And furthermore, shifting to the left means that they came from a colder climate. So we have some very interesting information here. We have a diversity of individuals in terms of their strontium who did not grow up in Britain and came from a colder climate. The word Viking, although it shouldn't, jumps into one's head. So what else could we do? Oh, well, let me explain the oxygen a bit further. This is a map of oxygen isotopes. And again, the body fractionates oxygen isotopes. So you've got a value for drinking water, and then you have to convert it to an enamel value in the teeth, or vice versa. So these are the drinking water zones, and effectively the values that we saw in the human teeth pretty much push you into the dark green area, which has values about between 9 and 10. So into Scandinavia or more Eastern Europe. And again, this is something with isotopes. We can't say just Scandinavia, you know. The history and the politics of that time might suggest that, but the isotopes merely say for oxygen that they came from further east. So what we try to do with isotopes is kind of have a reconstruction of life. So the teeth that we look at, we normally look at the M2s, the second molars, because these mineralized at about the age of 6. So you are capturing somebody's childhood environment. Now that's kind of all we can do with strontium, but with other things, such as oxygen, we can look at bones as well. Now bones are a live material, and basically break a leg, it heals. Break a tooth, you've had it. You're into the dentist, and that's the difference. The bones regenerate, they turn over, and they turn over at different speeds. So the big femur is a slow turning over bone that probably gives you the last 10 to 15 years of an individual's life. The rib bone is a much smaller, lighter bone and probably tells you about the last 2 years of somebody's life. So this gives us a sort of oxygen trace from tooth to femur to rib. And if we look at the results now, what I've got here is the purple shows you the typical oxygen values for British individuals. Then you can see that the enamel values of these guys were about 15.5. The long bone was less, and the rib was less as well. So in other words, according to their rib bones, definitely 2 years before they died, they were in a climate that was cooler than Britain and was giving them a more easterly, colder signature. So these aren't people that just were raised in an east, I want to say Scandinavia, but raised in a more easterly area and then spent their adulthood in Britain. These are people who arrived in Britain within the last 2 years. Now, the next thing I'm going to have a look at is lead concentrations. So if we look at this, I've got some reference data here. The squares are 18th century industrial individuals, and you can see the absolutely horrifying levels of lead that we see in their teeth. And remember, this is childhood. The value of 1 that we have here is pretty much viewed as the boundary between what we call anthropogenic lead, in other words, lead that you've acquired through pollution, and geogenic lead, because we all pick up a bit just in life. There's lead in rocks, and you know, you eat a bit of soil when you shake your lettuce out, and this, that, and the other. Children, we will always have some lead, but as long as it's below 1 ppm, we tend to attribute that to natural geogenic ingestion. So that boundary line is between geological exposure and anthropogenic exposure, and 10 to 100 ppm is absolutely horrendous. We've then got the blue triangles, Romano Britain, again, pretty bad, going up to 10 parts per million. And then as you come down, we've got the Anglo-Saxons, who by and large don't seem to have a lot of anthropogenic exposure to lead. But then you go further down to the Weymouth individuals, and this is a log scale as well, so you're dropping well down, and you can see they have virtually no exposure to lead. And I find this very interesting because, again, when you think of heathen invaders, armor, metal, swords, you would think that there might be some childhood exposure if these things are being produced while, you know, locally, and you're raising yourselves in and around smelting and things, but these individuals have absolutely no lead in them. So again, does that suggest a rural? It certainly suggests a lead-free, pretty much lead-free childhood environment. So we've got other types of isotopes that, or other types of evidence for this that are non-isotope evidence. Now, some of the individuals, I think about 5 of them, had filed teeth. And this, I believe, is absolutely characteristic of Danish and Swedish individuals. And the idea is that you filed the teeth and then put sort of paint or wax or something, I think, in the filing, so when you grinned at people, you know, you looked scary. And I find a fascinating echo in this in watching the rugby recently. And I don't know if anybody else noticed, but the Romanians, a couple of the Romanian tooth guards have vampire fangs on. They've got vampire fangs on. So it's the same philosophy, you know, do as much as you can to scare the enemy. And I think, if we've got any dental people in the audience, I think as long as you file just the enamel, people say to me, oh, that must be awfully painful. But I suspect that if you're just filing the enamel and you're not going down to the dentine, it's probably not too painful, but I'm not going to try, but that's my sort of guess. Otherwise, if you got into the dentine, you'd get infections and all sorts of problems, I would have thought. Now, here is the Osberg ship from Norway. Sorry, Oslo, Sweden, Norway, Sweden. Oh, and this is the other interesting thing, I think. We have 54 men. Now, 54-ish men would be suitable as a crew of a larger Viking longship. Most of them are 20 to 30, but there are certainly examples where they go up to higher numbers. So it's not an impossibility, let's say, that that could be the crew of a ship. Now, this is the other thing that I find interesting, because when I started to look at the evidence we've got and try to understand where these ships originated from, there was, when I first started, the map on the left-hand side was very much the standard story, that those people that came over from Norway and Bergen tended to go across to Iceland or round the north and come round the west coast of Scotland, drop into Ireland. And so you had the sort of Norwegian heathens coming that way, whereas it was the Danes that came in more around the south of Britain and came in and inhabited the east coast of Britain, England. And that just doesn't work for me, because if we're looking at that Danish model, there is no way that Danes would have the range of strontium values and the range of oxygen values that we saw. We just cannot accommodate these individuals coming from Denmark. So in fact, some of them, the oxygen was so low that they probably either had to come from the Arctic or much further east, almost into Russia, one or two of them. So this next map I found more recently, and I think this is, as people have understood the trade routes that the Vikings used, you're starting to look at the fact that boats were moving all around the Baltic and in and around this area. And what I do wonder is whether or not we've got a ship here which basically traveled in and around the Baltic so that it picked up maybe close to Arctic individuals, came down, maybe even dipped into the Northern Europe continent before coming to Britain. And this also brings in another issue. So first of all, is this a viable model, that we've got a possible ship coming in? And again, back to the Chronicles, another interesting snippet, AD 992. The king committed the lead of the land force to Alderman Elfric, Earl Thorogud, Bishop Elvston, and Bishop Esquire, that they should try, if they could, to entrap the enemy. Then went Alderman Elfric and gave warning to the enemy, and on the night preceding the day of the battle, he skulked away from the army, to his great disgrace. The enemy then escaped, except the crew of one ship, who was slain on the spot. Now, under no circumstances am I suggesting that this text relates directly to what we've seen, but I think it provides, again, a model, you know, that they might have taken a crew of a ship, just arrived, dragged them off not far from the coast, and executed them in an area where they would be seen as an example to what happened to people trying to attack. So on that evidence, one can think of this as an enemy ship coming in to attack. However, I think there are other options. So if we look at the archaeology, it tells us that the men were mostly between 18 and 25. If we look at the carbon-14, it tells us that they were Viking period individuals. The oxygen tells us they weren't from Great Britain, but they spent their childhood in Scandinavia or Eastern Europe. They were recent arrivals in Britain. Tooth modification tells us that they included probably Swedish and Danish individuals. Lead tells us that the rural upbringing was a low exposure to lead, and their numbers are consistent with the crew of a single ship. So if you were to conclude this, I think there are several options. I mean, I know that it's exciting to think that it might be a bunch of Vikings, but were they heathen invaders? I don't know. Were they pirates? This suggestion comes from Swedish radio. They phoned me up. They said, will I do an interview? Swedish radio, I hear you're looking at this massacre of individuals. And the interviewer said, well, obviously they're not Vikings. And I thought, oh, gosh, what have I missed here? I thought, God, all the evidence. Certainly, you know, I wouldn't have said that. I said, oh, why wouldn't they be Vikings? No, no, they must be pirates. Oh, why? Well, Vikings would never get caught. So, so the other thing I wondered about was, we know that there were tax collectors. They were collecting Danegeld, sort of tax from the British. And I do wonder whether these people were traders, whether the older two individuals were the sort of key people, and the rest were basically oarsmen crew. I come back to the fact that they were young, they had no other battle scars, they were from a diverse set of origins. As I say, they didn't look like warriors. And in fact, something I've touched on, but is touchy, is the concept of, were there actually slaves? And did you actually have crews that were enforced and captured and made to paddle these boats? And I think that's something that's interesting. And I do think that some of the data, there's like a core group in the data that look like they're a group from one place. And interestingly, I find the most convincing place that those people could have come from was Northern Europe, not Scandinavia. And I do wonder whether there's an element of these ships coming in and enforcing labor from oarsmen and then heading off to Britain. However, basically, I'm running a bit fast because I couldn't get onto that website. But just an extra, Bluetooth. Anybody know where the symbol for Bluetooth comes from? Yeah, it's H and B for Harold Bluetooth. And that is, I think, one of the most fascinating excavations that Isotopes has been involved in that I know of, because I think the Isotopes themselves have told so much about the story. I was just going to see if I can find the website, because I think you'd be quite interested to see. If I can just get onto Google, I can find it. Yeah. If you can find Google, I'll show you how it works.